Let's wait for a few more people to come in. Yeah, I think it's fine for you to, it's fine to start sharing screens, I think.
Okay, set it up. Um,
Shall we get started? Are you ready?
just want to set
Yeah,
up the chat so I can see it, or do you want to monitor the chat and let me know if there are questions?
we'll monitor the chat for you, so don't
Okay.
worry about this. Okay, but
And the
if
microphone's
you
okay? You can hear me okay?
yes, I can hear you okay. So let's get it
Yes.
started then. Okay, so hi everyone. So welcome back to this DEGAS webinar series. So today it is a pleasure to have Gal Mishner from UCSD to be with us. So let me first introduce the speaker today. So Gal is an assistant professor at UCSD in the Data Science Institute and also affiliated with the EC department, the CSC department, and also neurosciences graduate programs. So her research interests include high-dimensional data analysis, geometric representation learning, image processing, and computational neuroscience. So prior to UCSD, she was with Yale University, and even before that, she completed her PhD and bachelor degrees of the Technion University in Israel. And also, she was a 2017 Rising Star in EECS and also an emerging scholar in science. So today she will be sharing with us some of her recent works on manifold learning. So the floor is yours. Please join me in welcoming Gal.
Thank you, and thank you so much for the invitation, and thanks to those who are submitting a paper to NeurIPS today and are still in this talk. Appreciate that. So this work is low distortion embeddings with bottom-up manifold learning. This is work primarily led by my PhD student, Drew Coley, who is co-advised with Alex Cloninger here in the math department, and our collaborators Bas and Devika, who are at Erasmus University in the Netherlands. So just as a very brief overview of what my lab does, we primarily do geometric representation learning. So like many of you, I'm assuming in this seminar, we view the world as lying on a graph or as a network, whether that graph is on the sample space or on the feature space. And we develop methods from nonlinear manifold learning, which is the focus of this talk, but also to analyze objects like tensors, tools from graph signal processing, geometric deep learning, graph neural networks, and spectral graph theory. And we primarily collaborate with neuroscientists. So we work with neurobiologists who study neural activity from the brain. And we'll see some of that show up in this talk as well as we apply our manifold learning techniques. So I'm going to start out with an introduction, then introduce the concept of distortion, and detail the different parts of our bottom-up manifold learning approach, which has two phases to it. The first is constructing local views, and then constructing a global embedding from these views, and a new evaluation metric to evaluate the quality of low-dimensional embeddings, which we call global distortion. And finally, we'll apply this to neuroscience applications. So as a bit of motivation to get us started, let me see if I can get the video to work. As I mentioned, we collaborate with neuroscientists, and in over at least the past decade or so, neuroscience has shifted to collecting very large scale data sets where they can simultaneously